Up next is Knox Carey, who is a health data expert, and I'm hoping he'll be able to enlighten us a little bit about more on that topic area. So please give a warm welcome to Knox.
All right. So this is stuff I've thought a lot about. Most recently, I've worked on healthcare applications. I titled the talk "Taking Patient Rights Seriously," but it could just as well be titled, taking consumers' rights seriously or taking people's rights seriously. But it has a bit of a healthcare flavor. All right. So commenting on the title, actually, the first thing I thought of when I wrote this title was, geez, when somebody tells me that they take my privacy or my rights seriously, I tend to go, oh, shit, what happened? So here's a little lexicon, a phrase book. We take privacy seriously means something bad has happened. We take your privacy seriously means something bad has happened to your data. And we take your privacy very seriously means please don't sue us, the world is ending, et cetera. So with that caveat, I thought it would be good to talk about what would a world look like where we actually did take patients' rights seriously, or consumers' rights in their data, or so forth. So let me talk about some of the challenges there. I'll set the context in a healthcare setting. Really, the first challenge is understanding what the problem is. Why do we need to care about patients' rights at all, right? Don't the data live in some data center and the company that holds it is going to protect the data on our behalf and so forth? That used to be true, but it's increasingly not true. So the nightmare scenario is you have a pile of hard drives in a box under a desk in Boston. And somewhere on one of those hard drives is some data that a smart scientist could use to address a disease, all right? That scientist is in Japan. He has no access to that box of hard drives. All right, that's kind of the nightmare scenario, because that means humanity has collected data that can cure disease, but it's sitting over there in a box, and it's not over here, right? So the old model of data just sits there and waits for smart people to come to it and analyze it, this model is eroding. It's disappearing, fortunately so. What has to happen is the data has to get out of that comfort zone, right? The data has to go to Japan, or the person has to go to Boston, or the analytics that the person wishes to run need to go to a data center where they can run on that data, right? So things have to start moving around, and in that context, you're going to have people's really sensitive information all over the place, and you can't rely on one ecosystem or one company to say, yeah, I'm going to protect it for you end to end. It's going to go through many, many systems. So it's an inevitability that data are going to be shared, they're going to be distributed, and we're going to have to deal with this question of patient rights in this big distributed system. So how would we actually do that? That's what I want to talk about today. So what gets in the way of this stuff happening, of data sharing, things like that happening right now? Well, sort of three big things that occur to me. One is competition, right? Some researcher is sitting on a pile of data that they don't want to share because they've got to scoop the other guy. There's just actually very little that we can do about that, other than to appeal to people's sense of altruism. The other two challenges are kind of more tractable. Compliance. A lot of times data sits there because people are worried that they'll violate HIPAA or they'll violate the GDPR if they move data around from place to place. Fact is, you have people look at it this way: when you export data from your institution, it's out of your control. You have no idea what's happening to it. You're kind of throwing it over a wall. So that's too risky for the lawyers to deal with. So that tends to get data stuck in certain places. The other problem is standards. Maybe you want to share data, but there's no common gauge of rail. So I got a picture of a guy who improvised something with some nail clippers there. But those two problems on the right are tractable if we think carefully about an ecosystem that would protect patient rights in a distributed way. Okay, so the first issue, and by the way, the previous panel was fantastic because it perfectly set up almost everything I want to talk about. The first question is about identity. And so I don't know if you guys know this TV show, The Prisoner. If you don't, highly recommend it. One of the taglines in the opening is, "I'm not a number, I'm a free man." Well, right, Of course. You're not a number. It's true. You're very, very many numbers held by very, very many different people. So I have identities with all of these institutions that have given me identity. Google knows an awful lot about me over here. There's no single, the status quo is there's no single source of identity when we want to talk about managing your data. So when you want to say something as simple as this is my data and this is what I allow to do with it, who am I in that thing? So this is an important question. So how do people address this? Well, one way to do it is to have a single identity provider that works for everybody. And of course, that won't work nationally, but there's some examples here. So the Republic of Estonia e-residency program, right? So you can get an e-residency in Estonia. I was going to put Steve Jurvetson's e-resident card on there, but I thought better of it today. The Social Security Administration creates one, but that's got its limits, right? So after Equifax, I assume my Social Security number is floating around everywhere by now. There's one in India. So the problem with these systems, they're great in that they're really simple and they're interoperable. And if you can get people to play nice and use this identity, everything's great. But a third party controls your identity, and there's sort of a single point of failure. So these leave something to be desired as a single source of identity. One interesting healthcare thing I would mention, when you don't have a single source of identity, so a lot of people in healthcare talk about, wouldn't it be great if there was a single medical record number? Everybody in America had one, and everything was pegged to that. Well, in fact, there is. It's produced by this company called IMS Health, and you'll see some of their stats over there. They're involved in something like 90% of global pharma sales. So every time you go to the pharmacy, they buy the data from the pharmacy, and they're keeping a dossier on you. So their identity, their identifier for you is a de facto single identifier for healthcare in the United States. But of course, they're making a lot of money on the back of your data that you might not really want to be out in public. Okay, so then if you don't like the single identity provider, you can look at federated identity providers. And there's technology out there, OpenID, OAuth. Everybody's familiar with the type of thing on the right where you log in with Facebook or you log in with Google. As the previous panel talked about, those companies now control your identity. So there's an issue, but there's a way to federate those, right? The technology exists to federate those identities, and that's an important sort of middle ground. To go a little bit further toward a more decentralized identity, well, there are projects like the UMA, which is an OAuth profile that lets people assert their attributes about themselves, operate their own authentication servers. I know I do. I don't know about you guys. Then there are sort of blockchain-oriented things where attributes about you are recorded in a blockchain, and that state is made public, and people can rely upon that. So there's a spectrum of technologies all the way from, let's centralize everything to federated to decentralized distributed. And I think that reflects the order that things are going. I'll talk more about that in a minute. Okay, so let's assume that we sort of know who we are. Let's talk a little bit about how you would express your rights. Like, how would you actually say what you want to be able to happen? So I have a son. I have a school-age kid, so you can imagine I'm very familiar with sentence diagramming. So I thought this was an interesting way to think about the problem. A simple statement like, I want to share my data. There's a lot bundled in there, all right? When you say I, that means we have to have some notion of your identity. Who are you? The things we just talked about. When you say, I want to share my data, you're saying something that you want to allow to happen. So you're making a policy statement. The word my reflects some sort of binding between your identity and this data set. And data, that refers to some specific set of data. So there's a lot of sophistication bundled into people just say, why can't I just own my own data? Why can't I control how my data is shared? There's a lot of really deep technical stuff buried in that really simple statement. So when you move on from the simple sentences to say, I want to share my data with my doctor, you start to add even more semantics on that. So the second my is some sort of link between me and my doctor, like what's the relationship between the two of us? And the word doctor itself it can be an identity that can mean a specific person, or it can mean a particular person in a particular role. So there's a lot of technology behind a simple statement like this. And if you really generalize this, it can get arbitrarily sophisticated. I want to share my genomic data with my healthcare providers. I want to share my anonymized genomic data for academic research. I want to share my anonymized AppOE status. So each one of these things has really deep technical implications. In fact, in the limit, this can be really complicated. So let's see if I can, not to scare you too much, but here's a diagram I drew with a very simple use case, believe it or not. The simple use case is I'm being treated at a hospital, and my doctor is participating in a research project with some university. Can a postdoc at that university access my data? Right? Seems like a really simple use case, but if you think about all the entities and the relationships between them that are involved in that, it's a really complicated graph. Right? So the doctor treats Knox signs a consent, the IRB has approved that consent, and so forth. A lot of relationships here bear on whether that access should be allowed. So if you really boil it down, it's a very, very complicated story. So clearly, you're not going to present a user interface like that to somebody. You're not going to say, here, rearrange this graph to express your preferences. So what people do instead is they do something like this. They say, well, OK, that's too complicated. Let's boil it down into green, yellow, and red. Green means yes, yellow means maybe, red means absolutely not. So they tend to dumb it down in a certain way. Here's another example of a user interface that somebody actually created for this purpose. It's terrible. It's a really bad user interface. And what's worse than it being a bad user interface is that everybody who decides they want to boil down this question is going to do it in a different way. Right? So what's going to happen, inevitably, is you're going to have these sort of semantic mismatches. You're going to have people who want to express one type of permission and other people who don't have that in their vocabulary. Right? So you get into this complicated semantic mismatch situation that's really hard to deal with. OK, so let's say that somehow you've solved that problem. You're moving on to the next challenge. OK, I've somehow expressed my rights. Now I want to enforce them. All right, or I want systems to enforce my preferences. So what does that mean? Well, the picture over there is, I guess, a picture of New York. I can't even figure out if I should park there. But typically, there's a couple of ways to think about how rights get enforced. One is sort of declarative. We agree on some vocabulary about what my rights are and how do I express those things and what do those things mean precisely. We eliminate the semantic mismatch by just agreeing on everything. There's another way to do it. We explored a lot at Intertrust, a more imperative way that says, I'm going to run this program, and that program is going to tell me whether this is allowed or not. But both of those things require a lot of agreement. I've seen the declarative approach produce specifications that are 800 pages long, unwieldy. The imperative approach requires people to implement things the same way. It requires compliance and so forth. So there's some real complications buried in enforcing the semantics around the rights that people assert. So there's also a lot of issues that come up with DRM, something we know a lot about. Data encryption and key management, endpoint security. I took this picture of the guy protesting DRM. The funny story was, when I went to the internet to get that picture, a little thing popped up and says, attribution required. So I said, screw that. All right, forget that. OK, so those issues pop up as well for enforcing rights. Why do we want to enforce rights? So, one of the key reasons is I want to make sure that no information, especially if it's private information, no information is revealed about me except with a positive policy decision. Somebody has actually evaluated a policy and said, yes, this can happen. And so we need to protect that abstraction. that nothing happens without a policy decision. And the panel before alluded to some technologies for that, homomorphic encryption, secure multi-party computation, there's obfuscation and tamper resistance, secure hardware enclaves, things like that. I'm just gonna, I'm gonna assume most people kind of know what homomorphic encryption is. I'll gloss over that a little bit. I did want to mention one of my favorite applications of secure multi-party computation. This is an Icelandic app. So this big problem in Iceland is everybody's related to one another, right? So if you're at a bar and you meet somebody, there's a very real danger of you going home with someone who's too closely related to you. So this secure multi-party application allows two people who have genomic information about themselves to bump their phones together to determine their degree of relatedness without actually revealing the underlying genomic data. I thought that was a great application because it says, oh, you're second cousins. Maybe, just have a coffee. So that is by far my favorite application. OK, so moving on from confidentiality, there's an area that I call information dynamics. You may call it disclosure control. People use different terms for it. The idea is eventually, no matter how well you protect the confidentiality abstraction, no matter how invisible data are as they're being computed on and so forth, at some point you have to answer a question. And that question reveals information about underlying data. And the question is, how much? And can we control that? Can that be quantified, and can we manage how much information is disclosed? There are a lot of techniques for doing this. Anonymization, differential privacy, some people look at information metering. A lot of ways to do that. It ends up being a big sort of cat and mouse game where you try something and people break it, and you try something else and people break it. This is a really big challenge over and above just doing secure computation on data, right? Because as soon as you answer a question about data, if it's a useful question, you're revealing information about the data, right? So quantifying that and controlling it is an important thing. And it's a one-way street, right? The more questions you answer about a data set, the more it leaks, the more private information leaks over time. And you can't put that back in the bottle. Small digression here onto some stuff about genomics. I thought it would be interesting to explain some of the risks in even sharing little bits of data about genomics. This is one of my favorite examples. Somebody who models 3D facial shape from genomic data. They use about 400 polymorphisms in the genome to do this. And just for reference, if you do 23andMe, they take 1 million samples. And so they only use 400 of those to come up with this stuff. And so the picture on the right-hand side shows if you're mathematically inclined, shows the principal components for this particular study. The picture on the left is my former colleague Bart. That picture there was generated from his 23andMe data. And if this works, we'll see if it works, it will slowly morph into his actual photograph. And we'll see how similar they are. I think it's working. Yeah. Right, so there's the real guy. Now, I'll go back. It's not a perfect likeness. Bart always said that that photograph looked like, or that generated photo looks like him when he was a teenager. Still got some baby fat on the cheeks and so forth. But especially the nose shape, actually, is strikingly correct. Right, so I think that's way better than a police sketch, and that's done with a very, very small amount of data. 400 polymorphisms out of 1 million that you could get off the street. Here's another interesting study along the same lines that shows the sensitivity of some of this data and the reason why you'd want to limit the disclosure. So they took a bunch of samples of people in Europe, and they clustered them together based on genetic similarity. And I mean, I guess not surprisingly, people who live in the same geography cluster together. And this is powerful enough so you can see a distinction between the Portuguese cluster and the Spanish cluster. It's not great, but it's something. It's discernible. And and this is just from 2 principal components, and again, it's maybe 200 or 250 data points from your genome is enough to narrow that down. So there's a lot of information inherent in your medical data that you just don't want to disclose. Okay, all right, so moving on. 7th challenge, data integrity and audit. This was also touched on in the last panel. I think committing information to the blockchain is a really, really promising way to start thinking about this problem because it can deal with data integrity that was addressed on the previous panel. You could also consider storing state for rights in a blockchain. So if somebody wants to say this can happen, they can make that assertion and record that in the blockchain. It's indelible. It's provable and so forth. If people want to make assertions about my identity or other attributes about me, they can make that assertion. That can be stored in a blockchain. So there's a lot of potential to that. I have to point out, though, that it's in this huge hype. I'm almost hesitant to bring it up. Apparently it's past the peak of the Gartner hype cycle. So it's on its way down into the trough of disillusionment. What I think that means, actually, is that people who know what the technology can do are sort of buckling down and figuring out how to actually use it in a practical way. I hope that's what's happening. I know that's what's happening amongst the smart people I know at Intertrust. So, and I love this roller coaster guy. Right, this time it's different. At some point, this whole hype cycle is being driven by Bitcoin, right? Okay, so even if you've got an identity, you've expressed your rights, you have a uniform way of enforcing your rights. You record assertions about data. I want to be able to share this particular data. You record that in a blockchain. Everything's great. Well, you've recorded a hash in a blockchain. But what about the original data? How do we make sure that data is available persistently? That's another really big problem. And there's a number of options. You can store it yourself. You can give it to a trusted third party. I think the more sort of trendy approach would be to look at distributed hash tables or content addressable storage, things that BitTorrent really pioneered back in the piracy days. The successor, I think, to a lot of those ideas, and a nice resting place for many of these things is the Interplanetary File System, IPFS. They've captured a lot of that thinking into their system. It's still very sort of alpha, but if you're interested in this topic, I would recommend that you try it. It's really interesting. Discoverability. So, even if you've got the data and you've got the rights and everything is perfect, how do you actually find stuff, right? You're a doctor doing a study on a particular disease condition. How do you find patients with that disease? How do you find patients with a specific set of genomic markers? Well, it's a tricky problem because if you make that information available, that's also a channel through which private information can leak, right? So there's this really fine line between discoverability of data and actually disclosing things that should be private. And like I said, that privacy is a one-way street. People don't suddenly know less about you over time. They may forget. So it's important when we talk about discoverability, it's important to understand the sort of information dynamics. I spent a lot of time working with an organization called the Global Alliance for Genomics and Health. They put together a system called the Beacon Network, where data sets can say, hey, I'm open for business. Ask me questions like, has anybody ever seen this particular variant in this particular position on the human genome? And I'll say yes or no. Well, that ends up being a privacy hole. And there's a lot of research describing the types of private information that you could start to chip out of that really simple system. So it's really important to understand the information dynamics once we make data discoverable as well. And really, this is kind of a meta issue that I've heard in every talk today, actually, except for Max's. Well, actually, maybe even in Max's. Okay, so it's the idea of a trust architecture. So centralized, federated, or peer-to-peer, or decentralized. These types of questions have a really disproportionate influence on how we choose to, what technology choices we make. And I've described some of them before. A centralized trust architecture, it's technically the simplest thing to do. Like, if everybody just trusts my ID, everything will work fine. Well, it's technically simple. It's politically hard. It requires, neutrality for people to trust it. Maybe most importantly, it's a security monoculture. There's always a thermal exhaust vent, right? We've seen it in 3 movies now. There's always a thermal exhaust, yeah. So the second approach, federated trust models, it's like the passport system. There's no single authority, but there's sort of a bilateral or multilateral agreement among the parties to respect things. It does have a bit of a weakest link problem. You've heard of ships flying under the flag of Liberia or whatever. And then finally, there's sort of peer-to-peer or decentralized architecture where, this guy with gigantic forearms has as much authority as anybody else. But this can be really cumbersome. So if you've ever gone on the internet, you will have seen windows like this saying you can't trust this site. Well, this is an artifact of people rolling their own cryptography, rolling their own certificates and things like that. So there's a lot of really thorny UX problems that can come up with a decentralized trust architecture. As a whole, I think society is somewhere transitioning out of centralized or siloed models. I think the late 90s was very much on the left side of this graph. We're sort of transitioning through a federated phase now, and the avant-garde is actually looking at decentralized applications. But across the board, it's people are using federated systems. You're able to log into Pinterest using your Facebook ID, right? So people are using federated systems. Very few people at this point are actually using decentralized or peer-to-peer systems. But I think that's clearly the direction that the technology is trending. Okay, so wrapping up here. I've talked about 10 different challenges. This is just a subset. There are many, many, many more. For example, derivative work, right? What if you perform some transformation on data? Now what happens to the rights associated with that data? There's a lot of other really interesting questions. These were the 10 sort of pieces of low-hanging fruit, I think. I think some takeaway points, some approaches to addressing these challenges is one is to understand sort of this fundamental shift from centralized to federated to distributed trust architectures. That's really, I think, the key point. Recognize technologies that are already embracing those trends. This is a quote from William Gibson: "The future is already here, it's just not evenly distributed." I think that's very true. A lot of the pieces, parts that we need to assemble to take patients' rights seriously are there. They're not assembled in the right configuration. Finally, focus on user experience. The thing that will kill any sort of interoperability or faster than the technology being wrong is the user experience is too cumbersome. And we see that every time people try to do this. If you build a system that lets people control the rights of their own data, but it's really cumbersome and hard for people to set up, they won't set it up, right? So I think the user experience is a really important point to look at. And also to appreciate the role that standards play and to work together to solve these problems. I've done a lot of that in my career. I think that is ultimately the way this has to go. If we're going to have a distributed data ecosystem, no single company is going to control how that works. So standards are going to become very, very important, and people's goodwill to actually address these problems is essential. Okay, and that's my talk, so thank you very much. Appreciate it.